Welcome to my solution for the open address hashmap practice quiz. Let me restart the timer. And so, 15 minutes to implement the get method of a hash map or a map, and it's using open addressing with linear probing. So, it is a representation, a hash map using open addressing. Author Kim Moore. So it's public class hash map open, and generic, so we can take a key type and a value type. As long as they're objects, we're good. And there's a private entry, and this is the things we're actually going to store. We store entries, which are key values, and we have an array of them. So we're going to store the key and the value together in the array, and the array name is table. Okay, now we need to implement the returns the value associated with the given key. Boom, 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 boom. At ram key, the key. At return the value associated with the key. So public the get object key, and the reason we're using an object is because this is implementing the Java version of this, which they use an object, so anything could be the key. It could be also a K to make it type specific. So what do we want to do? Let me add the private class entry KV, and it has a private K key and a private V value. So the first thing we need to do is we need to get the hash code or the index into the table for our key. So we can do int hash equals key dot hash code. So that's a Java method that would return an integer, which is the hash of the particular instance of key. But that's a number, that's an integer, so it's too large. We have to also mod it by table.length so that we can get a number between 0 and the length of the table, but the hash code can be negative, so that might return a negative number. So you have a couple of options here. We can do math.absolute value, which will give us the absolute value of that integer, or alternatively int hash equals key dot hash code mod table dot length plus table dot length. So that will add that whatever the length of the table is to, even if it's a negative number, that will make it a positive number. So either one, that's fine, it doesn't really matter. So now this, well, the hash is now the index in the table where we think the key or the value should be. So we need to check if table dot hash is equal to null. That means the value is not in the table. The key is not there. So we return null. There's nothing there. This key is not, the value is not associated, there's no value associated with this key. Now, you want to say else. Now, we found something there, so we found an entry. Now we want to say table.hash, which is an entry dot key is not, oh, else if, sorry. If key is not equal to key, that means we have an entry here, but it's not an entry for the one we're looking for, so now we got to do our linear probing. So hash equals hash plus 1, and again we need to mod it by table.length to do the circular around the end of the thing. And so now we can go back to the top of this and put this in a while loop. Int original hash equals hash, because we want to stop. So we want to say while, I gotta think about this. While table dot hash is not equal to null. Let's start with that. That may not be 100% correct. Okay, so now, so if the hash is equal to null, well, that's not going to happen. But we don't want to keep going around and around and around. Oh, I'll just do int count equals 0 while it is not null, and count is less than table.length. So if we visit everything, then we've gone all the way around. So this, I don't need that anymore. So if the value is, if the value is not the key, we increment the hash and we go on. Else the value is equal to the hash, or excuse me, the key is match, return table sub hash dot value. So we return the value associated with the key, because the key matches the key in the table, and then we can do that. And so if we get to, oh, and we need to count plus plus, so we, if that is, we incremented the count, and then here we return, we didn't find it because we got to the point where either we checked everything in the table or we found a null, we return null. So again, we want to calculate the hash of the key, the hash into the table, tells us what index we go to, and we then check to see that is there nothing there. If it's null, then we haven't stored anything with this key. If it is not null, and so there is something there and the key doesn't match, we need to do our linear probing and move down one, and then we use the mod table length to do the circularness around the thing. If the keys match, and I should probably do it this way, I'll change that to dot equals. Because that's I'm call the equals method on the key class versus doing the pointer comparison. So that we have that, if they're not equal, we do our linear probing by incrementing the index or the hash in the table by 1. Then we make sure that we go around the table. We increment our count because we don't want to keep doing this forever, because if the table's full and we're trying to get a new key, we could loop forever. So this will stop us from looping. And if we do find the key that matches, we then return the value associated with that key. And if we fall out of the loop because we've searched everything or found a null, we return null at the end. So a little bit confused about my approach to this, but basically you calculate the index into the table, which I'm calling hash. You then loop until you find a null, or you've gone that the table length times, because you've checked every key in the table. And if the keys match, you return the value associated with that key. If they don't match, you then do your linear probing. Thank you very much.